right. Why don't we work on one last recursion problem before we let recursion go? So this week we're doing a relatively shorter number of lectures. I'm only doing like 1.5 instead of 2 to 3 because it's A, the middle of the semester, and B, we're kind of in a good place right now in terms of material, and so I'm okay letting the lecture for the rest of the week go and letting you focus on the homework that you're going to have to do for the this week. All right. So anyway, let's do one more problem. So this problem we're going to call the let's see, let's go into recursion because that's where I want to do it. And I'll do a file, new file, and we'll call this BinaryToDecimal.java. So I'd like to write a program that converts binary number to decimal number. So I'm going to use the same kind of pattern here that I've been using for the other programs. I guess we need a little bit more here. Let's grab that. And we'll grab the main program as well down here. Close that, and then we'll add the main program, add a little bit extra here. Okay, and we're calling this BinaryToDecimal. Now, I think so the idea is we're going to enter a binary number. So we'll ask the user, enter binary number, and the user is going to enter the binary number, which we'll call, let's call it B. And then we're going to say the decimal equivalent is, and we'll print out the decimal equivalent of the number. Now, I want to do this a couple of ways. So the first way I want to do it is iterative. So what I mean by that is that we're going to use a while loop or a for loop to solve this problem. And then the second way we'll do it is we'll do it recursively. So we'll say via iterative, via iteration, and via recursion. Okay. All right. So we're going to solve this problem two ways. So the first way we'll solve it is iteratively, and the second way we'll solve it is via recursion. And the goal is you pass in a binary number B to this method, and it returns the decimal equivalent of that binary number. All right. So let's create an iterative and recursive version of these methods. So there's my iterative version, and here's my recursive version. And I'm going to return just a bogus value. So anything you pass in, no matter what the binary number is that you pass in, I'm going to return 42. Okay. All right. So that's sort of the rough outline of how the program is going to work. Let's just compile and run this. Whoops, I got to go cd into recursion. All right. And let's try that again. Okay. Looks like I might have misspelled something. BinaryToDecimal recursion. Oh, recursive. All right, let's try compiling and running that again. Enter a binary number. Okay, so I'm going to enter 1, 1, 1, 1. So that should be 15. Of course, it prints out 42. And you might be wondering, like, how does the computer know that I'm entering a binary number versus any other kind of number? It really doesn't. It's going to accept any integer, and hopefully the integer just has ones and zeros in it. That's the idea. All right, so B could be actually any integer the user types in, but really it should just be an integer with ones and zeros, and we're going to pretend that that integer is a binary number. All right, so let's think about an iterative solution to this problem. So we want to take, well, let's look at this problem. We've got 1, 1, 1, 1. All right, so I'll put this in comments. Now what we'd like to do is take that 1, 1, 1, 1 and kind of break it up into chunks. All right, and we want to break it up into chunks. We want to separate each one here, and whenever we encounter a 1 in the number, or actually another way of saying this, we'd like to break this number up into its digits. All right, so if we can break the number up into digits, we're going to be making some progress, right? So let's do that. While b is greater than 0, let's break up the number. I don't know exactly how this is going to go just yet. I'm thinking about it a little bit. But what I'd like to do is I'd like to do a systemout.println b divided by 10. Now, what would that do? If I had 1, 1, 1, 1, b divided by 10 would give me 1, the digit 1. It would peel off that first 1 from the 1, 1, 1, 1. Okay? So after I've printed out b divided by, oh no, actually b, not b divided by 10, b modulus 10. After I've printed out b modulus 10, what I'd like to be able to do is then shrink the number by 1. And so the way I'm going to do that is I'm going to say b equals b divided by 10. So that will reduce the size of b from 4 digits to 3 digits. And I'm just going to keep doing that until there are no more digits. All right? So let's see. Maybe what I could do is just do a little system out print line here. Breaking up number into individual digits. Okay, and what I'll do is I'll print out the number, the digit, and then maybe I'll print out some dashes there. So we've got dashes between the digits. Okay, and then I'm going to return 42. So I'm still not getting exactly what I want done yet. But remember, the secret to handling complex problems is to break the problem up into smaller steps. So the first thing I'm trying to do is can I break up this number into individual digits? And then what I'm going to do is every time I find a digit that's a 1, I'm going to multiply the 1 by some power of 2, and eventually I'll get to a decimal result. All right, but right now I just want to see if I can break the number up into digits. All right, so let's see what happens when I run this. Whoops, missing a little semicolon there. All right. 1, 1, 1, 1. Okay. So it looks like I was able to break up 1, 1, 1, 1 into 1, 2, 3, 4 digits. So need a little system out print line to make that look nicer. Kind of picky here. I like it to look cool. All right. Cool. Okay, let's run it one more time. 1, 1, 1, 1. All right, still not getting the right answer here, but now you can see I've broken the digits up into their individual pieces. Okay, cool. So the next thing I want to do is I want to multiply the number that I'm adding to the result. So I'm going to have a result. So let's set up my result here. Int result equals 1. We'll start out with the result equal to, I guess we're going to start out equal to 0. All right. And what I'd like to do is I'd like to say result equals result plus b modulus 10. That's the digit. Like I just peeled off that 1. And why don't I multiply it by 2? That seems like a reasonable idea. So like every time I peel off a 1 from this number, as I break these 1s off and I get more and more 1s off the number, I'm starting from the right-hand side and I'm doing a modulus 10, that'll peel off that 1. And then after I peel off that 1, I shrink the number and I'm left with these 3 digits. Then I peel off that 1, multiply that 1 by 2, shrink, peel off that, and I end up with these 2, peel off that number, then I end up with this, and then I finally peel off this and I'm done. I don't have any more digits to process. Okay. So now I'm taking the result and adding whatever the current value of result is. I'm adding the digit, which is going to be 1 or 0, depending on what the binary number is, and multiply it by 2. Let's see if that works. So 1, 2, 3, 4. Oh, it's still saying return 42. So we want to say return result here instead of 42. And let's see if we can get this to work. 1, 2, 3, 4. So the iteration, the recursion one's always going to return 42 until we fix it. The iteration one is going to return 6. I don't think that makes complete sense. Let's see. 2, 4, 6. What's weird is I would have thought it would return 8 maybe, because I've got each digit is 1 here, and I've got 4 1 digits. So let's take a look here. Oh, I have to wait to do my division by 10 until after I've accounted for the digit and the number I'm processing before I shrink the number. Let's see if that's where we get now. Hopefully I'll get 8 here. Well, I got 6 that time, but let's run it again. I was doing 4 digits. Okay, now I'm getting 8. So 8 is kind of a counting of the number of digits I have. I have 4 digits. I'm multiplying each digit by 2 because I'm trying to convert from binary to decimal, and I end up with an answer of 8. But that's really not what this number is. This number is 15, and that's because each one of these digits needs to be a power multiplied by a power of 2. So this, if I expand this over to these 4 digits here, this first digit that gets printed out should be multiplied by 2 to the 0. Second one should be multiplied by 2 to the 1. The third should be 2 to the 2, and the fourth should be 2 to the 3. So that's kind of how we want to get our solution working. And so if that's true, we don't really want to multiply the digit we extract from the number by 2. We want to multiply it by math dot POW and math.POW, and that'll raise something to a power. We're going to raise 2 to the power, and the value that we want to raise 2 to the power to is basically, we'll call it power. All right, so power is a variable. It's a counter variable that we're going to use, and every time this loop iterates, we're going to raise power by 1, and that should basically do what we want to do. If I go back over here and just, maybe I'll add some spaces here. Whoops, not sure what just happened there. All right, this first one right here, that should be multiplied by 2 to the 0. The second one should be multiplied by 2 to the 1. The third should be 2 to the 2, and the fourth should be 2 to the 3. And then all of those are supposed to get added up. So this is extracting the digit that we're working on, but we need to know where the digit sits within the number, and that's what power can keep track of. This is position 0, 1, 2, 3. So what we're going to do is we're going to initialize power to 0. And then we're going to say, do this multiplication. So the first digit will multiply, if there's a 1, it'll multiply that by math.pow 2, 0. 2 to the 0 is 1, so that will be correct. And then what we need to do is we need to make sure that power gets incremented so that the next time we do the loop, we'll raise the next digit by math.pow 2, 1, so that'll be 2 to the 1, then 2 to the 2, then 2 to the 3. I'm feeling pretty optimistic that this is going to work now. So let's give it a shot. Math.pow returns a double, so we'll have to make that an int. Okay, let's try that. It's happy now. 1, 2, 3, 4. Sweet. So check it out. Decimal equivalent is via iteration 15. That is correct. Let's run it again. 1, 2, 3. This should be 7. Yep. 1, 0, 1, 0. So that should be 10. Yep, that's 10. Fantastic. What's interesting here is that now you're seeing the number being printed in reverse, which makes sense because the way this is constructed, we extract the first number first and then print it out, and then the second number second, and the third number third, and the fourth number fourth. Okay, we don't actually need to print out that number anymore, so we can get rid of that print statement because we have this working. All right, let's just test it one more time. So that is going to be 8 plus 4 is 12, 13. 13. All right, excellent. So I feel like we've got this working now, at least the iteration version, but we'd like to do the recursive version as well. So to do the recursive version, we have to think about solving the problem in terms of a simpler version of the problem, okay? So we've got a clue here that the result is being built up by taking, basically by this expression, okay? So the result is built up by this expression. And so maybe what we could do is see if we could come up with kind of a recursive version of the same thing. We'll just kind of experiment with it a little bit. All right, so let's take this expression here and say, if you were to say, that you wanted to take the binary to decimal recursive conversion of B, you would say, please return result plus B modulus 10 math 2 to some power. So that's something else we're going to have to wrestle with, is that what does that math 2 to the power mean? But part of our solution here is definitely to do this. For the current value of B, whatever that is that's being passed in to binary to decimal recursive, we need to extract the digit and also somehow raise that digit to a power and keep track of what that power is. But then also, we need to come up with a simpler version of that result. All right, and so that is going to be binary to decimal recursive B divided by 10. So what we're doing here is we're saying, all right, take the current binary digit, and somehow we have to keep track of that power thing. and then add to that the processing of the rest of the number. That's pretty much what this is doing, what that binary to recursive is doing, is add to that the rest of the number. All right, so there's one thing we have to figure out. Well, a couple things we have to figure out. This is the recursive case. We also have to figure out what the base case is. We have to figure out something that will stop the recursion. So we'll think about that for a second. When do we want to stop processing a number b? Well, there's a clue here, right? When b is 0, we pretty much want to stop processing, right? We don't have anything left to do. So if b is 0, we should just stop. If b equals 0, then let's just stop. And what we'll do is we'll return 1. That's pretty harmless. Oh, I'm sorry, we're going to return 0. That's even more harmless, right? So if you call binary to decimal with the value of 0 and you pass it in, we're going to return 0. All right? And the recursive case is anything else. Well, we're getting closer now. So if we pass in a binary number that is the value 0, in other words, there aren't any digits left and the value is 0, we're going to return 0. And that 0 would get added to a result that we're building up over and over and over again as we do recursive calls. If we pass in anything else, like let's say we pass in 1, 1, what we're going to do with 1, 1 is, let's take a look at an example of 1, 1. If we passed in 1, 1, what would happen is we'd extract the first 1 and we'd say that's going to be 1 times 2 to the 0 plus binary to decimal recursive of 1, because that's the next number. Now the only reason, so this seems to be heading in the right direction, but I can see a problem, which is we're not really keeping track of this power thing. It would be really nice to have that power thing work so that that the power value rose as we broke the number down. And so there is a way to do that. If we just add power here as an argument to the method, and when we call binary to decimal recursive, we'll start out with 0 as our initial power. So that will make this part work here. And then when we call binary to decimal recursive, here in this expression, we're going to pass in the number b reduced by 1 digit, and we're going to increase the power by 1. So now this power will get this power plus 1. So let's do an example here since we started working on this. We'll just do a full-blown example, okay? I'll do it up here as a comment. Seems like this is indented a little bit more than I might want. I guess that's good. Okay, so let's do an example right here. All right, so we call binary, oh, and I gotta end the, okay. We call binary to decimal recursive with 1, 1, 1, we'll just do 7, and 0 as our initial power value, all right? So that's going to create an expression, which is this. Return this whole thing. So that's going to yield this. This expression has to be returned. All right, well, b modulus 10 is going to be 1. Math 2 to the power is going to be 0, 2 to the 0. And then plus binary to decimal recursive b divided by 10. Well, 111 divided by 10 is 1, and power plus 1, power was 0, so power plus 1 is 1. All right. Now we can't solve that expression until we handle this. This has to get resolved. All right, so how are we going to resolve that? Well, that's going to be this expression again. But we'll fill in what it is. B divided by 10, we're passing in 11 here. So b divided by 10 is going to be 1. Math power 2 to the power is 1. So we're going to say 2 to the 1. Binary to decimal recursive b divided by 10. 11 divided by 10 is 1. And power plus 1, well, power was 1 right here. Passed into the method, and now it's going to be 2. So that expression can't be resolved until we figure out what the next expression, the next call to binary to decimal is. So we're going to have a return b divided by 10, last one, so that's going to return 1. 2 to the power, well, the power is 2, so 2 to the 2. Binary to decimal b divided by 10. Now we have 1 divided by 10, which is 0. And the power plus 1, the power is 2. So power plus 1 is going to give us 3. Okay. Now we're going to return 0. And the reason why is b has the value of 0, so that's going to trigger this base case. Okay. So if we return 0 here, then it means that binary to decimal recursive 3, that's going to have the value of 0. That's going to be 0. And this 1 times math power of 2 is going to be 4. So this is going to be 4 plus 0, which equals 4. Okay. So that 4 is going to be returned to this expression. And then we're going to have this will be evaluated. So this is 1 times 2 to the 1, which is 2, plus 4, which is equal to 6. All right. So this value of 6 is going to be returned here. But we're also going to have this. That's 1 times 2 to the 0, which is 1. So we're going to have 1 plus 6, which equals 7. And that's our result. 7 is the thing that's going to be returned. So there you have it, folks. We have both a binary to decimal iterative version that uses this loop, this while loop and some variables. And we have a binary to decimal recursive version, which uses a base case and a recursive case. And I would argue that the recursive solution is just a lot less code. It may be a little bit more challenging to come up with it, but as you practice with recursion, you'll find that it comes easier and easier to you. There are some languages, in fact, that will not let you do repetition in any other way other than recursion. So in those languages, you get pretty good with recursion really quickly. But a language like Java is really flexible, and you can make a choice when you need to about using one kind of language or another, or one kind of repetition or another.